Hi, everybody. I'm super excited to be here for many reasons. First of all, we share a common interest and we're colleagues, and there's ways we can help each other. There's some personal reasons I'm very excited to be here too, which will come up in the context of my talk. And I guess also because I feel like we're at a transition point in terms of how technology is going to impact healthcare. Right now I see the continents colliding. I see the consumer electronics companies such as Samsung and Apple and Google and Microsoft, Sony, all jumping into healthcare in a big way. And I also see the pharmaceutical companies, the medical device companies collaborating with some of the startups and digital healthcare companies. Finally, digital medicine is becoming part of the standard of care of medicine. And that's a very exciting time, and we're going to see some dramatic changes. As mentioned earlier, I'm a behavioral scientist, a research scientist. I work at Stanford, the Virtual Human Interaction Lab, and also over at the Children's Hospital. I'm also working with a group focusing on applying digital health technology to mental health issues out of the University of Colorado. I have a talk that I usually spend about an hour doing, since we only have 45 minutes. I'm going to skip every third word. This is a very smart group. I'm sure we can get it, but please also listen by dynamic. If it's anything you disagree with strongly or really like a lot, stand up and say so, or ask a question. Now, I think there's four things when I talk to the people around my university about what we should be worrying about as a culture. Four things come to the surface, and from my viewpoint, it's the healthcare crisis involving an aging population that is the biggest worry. Since we were kids, the US population has doubled, and we have a huge problem with not enough youngsters to take care of the aging population. This is not a matter of theory, this is just a matter of math, of doing the demographics, of adding a few years to the current boomer population. We don't have enough of an infrastructure to take care of an aging population, especially since 2 out of every 7 of us are going to end up with a neurodegenerative disease. So we need to come up with an answer for this. In my opinion, the only way out of this box is to use technology effectively. We have to do it, and we have to do it fast. Fortunately, there's a revolution going on in digital medicine right now. Mobile health with sensors, patient-centered changes where the patient becomes the center of care, not the clinic and the doctor, and leveraging what's going on the internet with AI technology, social technology, collaboration, connecting people in a very smart way to the healthcare infrastructure. Every medical device has been reinvented, from sphygmometers to thermometers to everything has gone from an analog world to a digital world. And this is being propelled quite a bit by the quantified self movement, where people are measuring everything about themselves and sharing that information with their clinicians and with their friends and colleagues. This allows us to collect a huge amount of data, and with AI and deep learning technology, to parse things out and to have a way for us to collect both population data and individuals' precision data and push interactions through a variety of mechanisms, ranging from just cell phones and computer-based systems, but also to VR systems, and to collect the information as the data comes back, parse it, come up with precision interventions, and provide that to the clinicians and to the research scientists. That's a big deal. But the purpose of my talk now is to focus on the medical applications of virtual reality technology, and I'll start by giving you an overview of what's been going on and then talk about some specific examples. Right now, every major technology company has put billions of dollars into investing in VR technology, not just the head-mounted displays, but the motion capture technology and the data analytics behind that technology, including the AR systems for avatars. Literally tens of billions of dollars. Right now, it's projected within 3 years, VR technology will be adopted by more than 30 million users. I'm curious, how many people in this room have used a VR system? Wow, almost everyone. How many have used a high-end virtual reality system where it's tethered to a computer as opposed to mobile VR? That's a pretty good number, too. 5 years ago, if I had said the term VR, most people wouldn't have known what I was talking about. But now, much like AI, people know what VR stands for. For the purpose of this talk, when I say VR, I don't just mean fully immersive virtual reality. I also mean augmented reality technology. I view it as a spectrum of immersion. We don't always have to have something on our head. And sometimes we even have rooms we can step into where we can interact with other people and have a 3D immersive experience. I think in the future, actually, we probably won't be wearing things like this. This is a fantastic device for right now, but it's sort of like the 300 baud modem days where we saw what was going on, we knew that things are going to get better, but we're not quite there yet. And that's where we are right now with VR technology. There's a lot we can do, and it's very cool stuff, but it's going to be so much better in about 5 years. So here's my overall perspective. I think although entertainment and gaming is going to drive the adoption of VR technology and get it into everybody's living room, it's going to move over to the enterprise. And the tech companies need to see that happen, or the billions of dollars that's invested will not give a return on investment. And I think the most significant vertical within the enterprise is going to be the medical market, and I'll tell you why. When I first got involved in this, and Beth, you recognize this machine, the silicon graphics machine, the computers we used were the size of a small refrigerator and cost $500,000. And the head-mounted displays were so heavy we had to counterbalance them back sometimes with a brick. This is how I looked like back in those days, sitting on a dumpster in front of the Department of Physiology. I had a lot more hair, and I think it's wearing those head-mounted displays that has contributed to my loss of hair. But things have changed. And during the last 3 decades, while I've been working in this field and my colleagues have, there's been a lot of great work that we can use now to leverage and see how this exciting technology can be applied. We have a huge amount of previous research studies. Now, granted, they were done with previous generations of technology. We need to redo them with the current VR technology. But they show us the pathway, what works, what doesn't work, where the blind valleys are, where the shipwrecks are, and where we can find results. So with the better technology, this VR system right now that I can get at a Best Buy for a couple $100 is better than that $500,000 computer that I was using many years ago, and it's very affordable, very portable. Back in 2008, I tried to help with the post-traumatic stress after the Sichuan earthquake in China, where more than 50,000 children who'd been in buildings that were very poorly designed had a traumatic experience. And we could not scale. That technology was too expensive and too cumbersome. Anyhow, after the 2017 earthquake, some of my friends were able to go into the earthquake area and bring some cardboard-based VR systems and help with the stress management immediately after the earthquake. So the point is, and also after the recent terrorist attack here in Toronto, David Parker reached out to me and said, can we do anything to help with this incident too? And we matched them up with some VR systems to help with the stress management after that. And I believe they also captured 360 video from the aftermath of that event, so they can use it for exposure therapy for post-traumatic. The good news is there are numerous companies working on VR and AR technology. The startup scene is very active in this arena. And in the medical arena, I've added up just recently 157 emerging medical VR companies in 20 different clinical sectors that I know of personally, and I'm sure there's many more that I haven't run across. And just to be clear, it really spans all aspects of healthcare. There's also a lot of money being invested in medical VR startups. Reflection Health, doing neurorehabilitation, I think has raised more than $20 million. Limbix, doing post-traumatic stress, has been funded by Sequoia. TRIP's been funded by Mayfield. Paratherapeutics is getting into VR applications. MindMaze, amazingly enough, has raised more than $200 million at a more than $2 billion valuation to do neuro VR applications. And Penumbra, a medical device company, has teamed with Sixth Sense to get into the medical VR arena. So it is happening from the bottom up with the startups, and in some cases from the top down with some of the medical device companies getting involved too. Right now, the recent Kinsey report is projecting that there will be a $5 billion market for VR technology in medicine in 2025. And that's just an incredible adoption curve. So why now? Well, previously it was too expensive. It was also bulky to wear the head-mounted displays. And I think also socially, the term VR, when applied to medicine, just didn't sound right. It seemed almost like we were being too flippant, too glib about it. But I think now, because VR is becoming more common in the enterprise, people are more accepting of its use. Also, we've had a chance to validate our approaches. I want to say, and this is an important point, it's the full stack of medicine that is being impacted by VR and AR technology. Starting with health and wellness, but improved assessments, more objective assessments, functional training instead of abstract training of events, improved interventions, mechanisms to facilitate adherence to a program, and distributed care delivery. In the area of medical training, it spans all aspects of training from just basic clinical training, but also team training, interpersonal skill training, how to use surgical tools, how to rehearse and plan an operation, how to have a group respond for emergency response, getting a whole city to network and capture information about how they respond to a citywide disaster. And also, this is an important point, because VR can allow us to have an experience of what it's like to be in somebody else's shoes, to have another point of view, to teach empathy. And that's a very important thing that we need to have in the medical care profession. We've had for decades VR systems that have been used for training surgical tools, but these have been very expensive, and you've had to go to certain regional training centers to use them. But now it's been democratized a little bit and moved to systems that can be used right before doing a procedure. You can learn how to use a new approach or plan the surgical procedure. Here's a quick video illustrating that point.
What we're expected to do when we're learning a new surgical technique is fly out to a remote cadaver course. We get a chance to practice in a hands-on way on a cadaver. However, you only get to do that once. Imagine studying for a test and then taking that test 6 months later, with no option to practice in between. It was with this knowledge and my background in game development that I founded OSO VR, which is a surgical training platform. OSO VR allows you to practice modern surgical techniques anytime, anywhere, in a hands-on manner.
We can bring new surgical techniques and technologies to patients and solve one of the most pressing problems associated with educating providers around the world today.
We're working to increase the adoption of new medical technology.
I think the key phrase there is anytime and anywhere. So this allows us also to push out our training to underserved areas. Here's an example by a company called SimTabs of using VR to do team training on how to do a dialysis procedure. You'll notice in the corner there's some gamification aspects of the training too. So, and here's one more example of how we can use the technology to also train the patient of what to expect and have them go through cognitively what the process is and participate in the decision-making about their medical care.
Hi, I'm Dr. David Axelrod, a pediatric cardiologist at Stanford, and we're taking medical education to a whole new level. Medical trainees will be able to see and touch a living, beating heart right in front of them, so they will be able to have a whole new take on how to learn about the heart. We're starting with congenital heart disease, which are structural defects of the heart that people are born with. They'll be able to actually go inside the heart to see the difference between a normal heart and a structurally abnormal heart with congenital heart disease. Our virtual heart goes so far beyond what textbooks, plastic models, and even cadavers have taught medical trainees for decades. It gives them a vivid, three-dimensional sense of how the heart works and what happens when it's not working normally. This is just a better way to teach our medical trainees, doctors, nurses, and even families about complex anatomy that they've never seen before.
I think the key point for me from that is not just training residents and pushing their training out to other hospitals that don't have an opportunity to come in and be trained under the experts here, but also to educate patients and have them participate in their decision-making. This was from a headline from a paper 2 days ago that I saw Gaming meets medicine to become a Nova Scotia neurosurgeon's essential tool. At Dalhousie University, David Clark is using this to plan and train for a surgical procedure. So this is coming out more than just from being a lab curiosity into something that's becoming part of the standard training and pre-surgical planning. The next phase of where medical VR is having impact is better assessments. And this is, again, the full stack of how we're doing assessments is being improved. Because we can capture movement and behavior in a virtual environment, we can do better objective assessments of function, not just physical function, but cognitive function. Instead of a subjective assessment where we ask people how they're feeling, we can study how they behave in a virtual environment, where they're looking, how long they remember to stay on the task, how long they can focus, what their functional results are to a challenge. We can also assess their mood by, again, looking at their behavior. And again, it doesn't have to be wearing a head-mounted display. We have rooms that people can step into to do a task, and we can study their behavior there and come up with a between subjects or within subjects comparison in a reproducible manner. Now, how many of you have walked the virtual plank in your VR systems? Only a handful. This is sort of almost a standard gimmick in many of the labs and demos I see, where they have people go up in an elevator and there's a plank they have to walk out onto and rescue the kitten at the end of the plank. And often people are so compelled by the visuals that they really can't even walk out on the plank. I'd say 30% of the people in our lab can't do that. Even though they know they're in a room and they're talking to their friends, their visual system is telling them something otherwise. And the point of this exercise, when it's done in a demo, is to show that we can elicit a cognitive state, one of apprehension and fear. If you can elicit a cognitive state, you can teach people how to manage that cognitive state. It's a very powerful thing. Getting to Tusi's point, how can we use emotions to help drive our interaction? VR is really good at inducing an emotional response. In this case, it's one of concern about falling, but we can induce other emotional states too. One of the projects we did at our lab was to come up with a library of different virtual environments that can be used to elicit different emotional states for research purposes, such as joy, sadness, fear. Some of the characters that you mentioned, Tusi, from the movie, we can elicit them in a reproducible way. And this is a publicly available library of virtual environments that can be used to elicit different emotional states for research purposes and eventually for clinical purposes. Already we're migrating those findings to precision medicine for depression, where we can study the systems involved, the neurosystems involved in different emotional reactions in an individual to find out what is the best approach to treat them. Is it cognitive behavioral therapy? Is it pharmacologically? If pharmacologically, what's the best medication to do that? But in order to do that, we have to have a standardized way of inducing a cognitive state. So we're seeing that VR is being applied to many specific clinical problems. I'll give a very quick overview. Just starting at the top of the list, looking at stroke rehabilitation, physical and occupational therapy, optical rehabilitation, pain management, weight management. In the field of behavioral medicine, there's a very long list. Psychosis, addictions, post-traumatic stress, generalized anxiety, depression, mild cognitive impairment, autism, Asperger's, ADHD, phobias, conduct disorders, eating disorders, impulsive disorders. If I didn't list your favorite mental illness, it's just because I didn't have enough time to put it on the slide. If we move into the field of health and wellness, we also have some amazing things that we're able to do by shifting behavior. We use VR. We have some different neurohack approaches to do it, leveraging the technology to shift people's interest in helping support their health and wellness. We've shown reproducibly that we can help with stress. We can help with mood and resilience. We can provide mechanisms to help with isolation, grief counseling, disability solutions. And I should point out something else here, and this is a key point. VR doesn't have to be a laboratory-based assessment or intervention system. Because we can do it on a cell-based system, allows us to reach underserved outlying areas that otherwise are very difficult to reach in a telemedicine manner. And it's not just the VR and AR technology that's helping us do these new interventions and new assessments. We're also getting a lot of momentum by our friends in the AI technology with virtual humans and AI systems that are behind it. I'm going to show you a quick videotape where we have a virtual therapist who is talking to a real patient. The AI system behind the therapist is studying the facial expressions and body language and voice tones of the patient and using that to change her behavior, the virtual human's behavior, in terms of her questioning.
Hi, I'm Ellie. Thanks for coming in today. I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes,
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself. When was the last time you felt really happy?
When was the last time? I don't know. Yeah, I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just,
In the mental health field, we sometimes have people who are on wait lists for months at a time. They finally say, I have an addiction, I have a problem with anger, I have a problem with depression. They make that difficult phone call and then they're put on a waiting list. So you can imagine that a virtual human, perhaps one a little bit more refined than that, could be used to provide information and support and maybe screen people to see if they should be put at the top of the list instead of left at the bottom of the list. But we're getting really good at these smart avatars. This is a system developed by a company in Pasadena, Oben. It's almost photorealistic, the avatar. They take your photo, they capture your voices, you speak for a few minutes, and all at once there's an avatar that looks like you, that moves like you, sounds like you. But guess what? That avatar, and it can be on your cell phone, it can be projected onto the table through an AR system, or it can be in a fully immersive system. That avatar can sing, even if you can't sing. Or that avatar can speak in another language, even if you can't speak Chinese. It's both powerful. We can use it for a post-discharge follow-up, for example, where you can interact with your clinician once you've been home and have the virtual clinician answer questions about wound care, for example. But it's also, I think, a little bit scary, the fact that we're going to have virtual humans that look and sound like us.
Hi, I am a virtual copy of Nikhil, made using Oben's artificial intelligence technology. As Nikhil's personal AI, I enable Nikhil to spend more time with his wife and 3 kids, enjoy a nice hike, or go off-roading. Ni hao, wo shi ni ka, lai zhe shui ni shi jie, wo zhang da shui, neng chang ga, neng tia wu, hai hui shuo jun wan.
I'll hold off on showing him dance, but it's pretty amazing. So let's get some specific real-world examples of how the technology is being applied. One area that we've been having great results for decades is using VR to help with exposure therapy for addictions and also for post-traumatic stress. Instead of asking the patient to imagine the worst thing that's ever happened to them, which is very difficult to do, we can gradually take them there in a staircase manner, providing support on the way, and take what's a limbic system reaction, a fear response that's been learned, and turn it into more of a frontal cortex cognitive response to a stimulus, and help people manage with their trauma. It's been most commonly applied for combat PTSD, but it's also been used to help with phobias and a variety of other issues such as sexual trauma. So these can be done typically in a co-located manner where the clinician is in the same room as the patient, helping them through it. But for some cases, such as perhaps fear of public speaking, this doesn't have to be done in a co-located manner. It can be done in a telemedicine manner. We also have better ways of assessing some aspects of cognitive function. This is a system developed by one of the companies that advise Cognitive Leap to do a better job of assessing attention deficit disorder. It's a virtual classroom with distractions in it, but it's not just the ability to evoke a standard way of measuring the response. There's a big, deep learning system behind it, capturing a lot of data so we can do a better job of analytics instead of just subjective assessments.
The Virtual Classroom Attention Evaluation System consists of a virtual classroom environment and utilizes the standard continuous performance test with multimodal distractions, as well as motion detection of the head, arm, and leg. The user takes a 13-minute test in the VR environment, and the CPT test results, as well as all movement data, are recorded.
So you notice that the test that they're using is upwardly compatible with the standard test. I think we'll start finding that there's inadequacies in the standard test, and once we come up with better measurement tools, we'll leave those behind. But currently what we're doing is we're taking some of the standard neuropsychological tests and moving them to a virtual environment. Another way we can use VR is to help teach refusal skills and situational confidence to those people who are dealing with addictions. We can evoke the cravings in a consistent manner and then teach people the cognitive behavioral skills to manage their addictions and their cravings and practice how to say no to peer pressure, for example. Another example of how we use VR technology clinically is in what we call stress inoculation, where we prepare people for an anticipated traumatic event. First responders, for example, we know they're going to have some very horrible days, and we can prepare them for it psychologically and teach them the stress management skills. One project I'm really proud of is a project we did at Stanford University called Braveheart, where we captured 360 video of the whole patient journey starting in the parking lot, and we green screened in kids who'd had that procedure before to serve as guides. We gave this to children who were scheduled, we know in advance what the worst day of their life's going to be, which is the day they go in for cardiac surgery. They know about it weeks in advance, so do their family members. So we captured the 360 video. We snuck in some mindfulness and relaxation training and diaphragmatic breathing skills into the system and put it on a cell phone-based system so they could take it home in advance, and their family could see what was going to happen, learn the layout of the hospital, and probably more importantly, the kids themselves would understand what's going to happen and be comfortable with it.
Braveheart is an interactive VR experience developed to reduce stress levels in children who will be undergoing a surgical procedure. Patients and their families are guided through a 360-degree video tour of the hospital by a virtual companion. The gender-specific tour guide provides a friendly, approachable, and relaxing tour of the facility and introductions to doctors and key hospital staff. Along the hospital tour, patients visit the key rooms they'll encounter on the day of their procedure to help make the unknown more familiar. Children learn about parts of the procedure and can even practice mindfulness and relaxation exercises. The intuitive software design allows the user to navigate through scenes and applications, learning the hospital layout, all within Braveheart at their own pace, creating a first-of-its-kind, interactive and immersive video environment. When Braveheart is finished, anonymous usage analytics are stored and available by scene, time, and engagement for analysis by doctors and researchers.
Another area where VR is being used clinically, actually rather extensively right now, is to help with distraction from acute perioperative procedures and pain, and also to address some issues of chronic pain. And we actually have a lot of data, including some neuroimaging data, showing that this is not just a placebo effect, but we're actually training how people are responding and reacting to the pain experience. We can see this when we do the neuroimaging. Here's a quick video about one example of a use case of using this. This is with a young man who was injured in a go-karting incident and had what they call a degloving injury, where a large part of the skin was pulled off of his arm. he refused to do some of the wound treatment that was necessary. He felt it was too painful and too distressing. But you'll see in this how, using a VR system, we were able to help him.
Yeah, it's usually just like a little packet. Okay, great. Look at him. Just knows how to whip it right on, get it all going. Kids are so funny. When they brought it into us yesterday, like no one knew how to turn it on.
Oh, wow. That is so cool. It's right there.
Okay.
That thing is. Oh, wow. That thing's
Okay, all
long.
right. Yeah, I would just fire it. All right, is it okay to start taking off the dresses?
Let me wash my hands.
No.
Oh, that's nice.
Okay.
Uh,
What are you watching?
I'm under the sea looking at sea snakes.
Sea snakes?
Yeah.
Sea snakes? Oh, this is the sea monster one?
No, not sea monster. I'm looking at sea snakes.
Go ahead, I'm
Like
taking
in
your-
the ocean.
Your sensor off, okay?
Alright. God, that thing's like 20 feet long.
Is it coming at you or is it just
No,
swimming around
it's
you?
just swimming around. It's a bunch of different kind of sea snakes swimming around.
That's cool.
Another example of how VR is being employed is in combination with some medical devices. This is a company I'm advising right now called Equality. They're developing a device that goes inside the ear. It's about the size of a small hearing aid, and it stimulates transcutaneously the auricular branch of the vagus nerve to change vagal tone. But the point is, they're not just making a medical device. They're hooking it up to a mobile health platform where they're going to use VR technology, music, assessments, a whole community building system. And that's, I think, where things are going to go. We're no longer going to see just a medical device rolled out on its own as an intervention, especially if it's in the mental health arena. It's going to be part of a platform which combines it with other aspects of therapy, including VR and AR technology. We can also use VR to help prepare people in the clinical zone to have those difficult, critical conversations, giving news of a terminal illness to a family, for example. Here's an example of a system. This was developed about 15 years ago. We can do much better now with some of the virtual avatars that we have. This is a woman learning about a breast cancer diagnosis. Well, you don't hear the sound, but that's okay. The point is that we can rehearse how different patients react. Maybe she's reacting in sadness, maybe she'll react in anger or withdrawal. You'd rather have your clinical staff learn how to do this in a virtual environment rather than on the job. It's so important to get that right. So let me talk briefly in the time I have left about some of the neuroscience behind this and why it works and how we can leverage it and applying it to some of the serious game technology that you folks are developing. We know that if we're going to change a cognitive system, we need to activate that cognitive system. And we need to activate the reward systems associated with it. That's where the neuroplastic changes occur. We have to make it cognitively engaging. We have to make it novel. We have to shorten the feedback loop. We have to give immediate feedback so that people can show the progress. And we need to leverage the mirror neuron systems in our brain. Repetition is required, but repetition can be boring. So unless we make it interesting and engaging using some of the tools that the people in this room have, it's just not going to work. And it's really critical to engage the brain's reward systems or we won't see any lasting change. One thing that's important to realize, though, one of the big evolutionary disappointments that we've have as a species is that we don't stay happy very long. Our reward systems are activated by the anticipation of a reward and not the actual reward itself. So as you design your systems, we need to bake that in to understand the neuroscience of what makes something engaging, what makes something rewarding. And it's not the accomplishment, it's the anticipation of the accomplishment. And there's, of course, a whole science behind this, but this is sort of the top level. It's sort of a bummer, though, that we work so hard for something and get so excited about something, but we can't stay happy in the moment for very long. One trick we use in our lab to modify behavior is leveraging the mirror neuron systems and have people bond with their future self. It takes 5 minutes, maybe longer, once you've taken your avatar and you see your avatar in a virtual mirror and you do some tasks and you realize that these are, the avatar's hands are connected to your movements, and when you smile, your avatar smiles. But if we age progress your avatar to create your future self, we can have it as a tool to shift people's behavior because you want to please your future self. It's very powerful, motivating. We did a study with Stanford students where we gave them some money, some actual real money. Those that had met their future self and had an interaction with their future self were significantly more likely, and this is amazing for undergrads, to put the money aside for a retirement account, whereas those who didn't get to know their future self, of course, didn't do that. And you can imagine just age progressing a Stanford undergrad for 5 years can be very scary, let alone 20 years. But imagine if my future self is on my phone and he's talking to me, and whenever I do something that is disadvantageous, such as not exercising or maybe going into a bar if I was having trouble with alcohol, or maybe not being active enough, my future self would call me up and complain. That could be a very motivating thing. Tusi mentioned earlier what's going on with the new generation of neuroimaging technology with FNIRS. I'm particularly excited about this because it can be used in a portable manner. It doesn't have to be in a big magnet machine. And we can understand not just how individuals are processing information and what's rewarding to them and where they're paying attention and measure what's going on in their frontal cortex, but also groups and see how groups make decision-making together, for example. I think this will be the next generation of biofeedback, biomonitoring technology. Just as EEG has moved from something that used to be a very expensive and difficult thing to measure, this technology will soon be something that we can put on a headband and have it be at a consumer price point. And I think this is combined with VR technology where we can expose people to situations that they normally would not encounter in real life and give them feedback on how to manage the emotion reaction to that stimulus. I think this will be a very powerful behavior modification tool. So again, just to summarize, and I've tried to pace this so that I have a few minutes for questions. I'm very concerned about the aging population and how we are prepared for that as a country, as an economy. Fortunately, many of the things I've talked about in my talk today address those issues. VR does address many of the issues of senior care, managing pain, helping with isolation, helping with depression and anxiety, physical and neurorehabilitation, designing for disabilities, helping with post-discharge follow-up. And there's a big problem right now with training caregivers, especially since we are going to need so many, but there's a big generation gap. So we can use VR technology to help them understand the seniors that they're working with and their history and their culture. So here's my summary slide. Current technologies have not just sprung out of the clamshell in the last 5 years, as many people think, but VR and AR technologies have been with us for almost 30 years. And there is a large amount of data that you can find on PubMed and other places about what works and what doesn't work. It's now very affordable. I think that VR technology will be the major vertical that the consumer electronics companies look to recoup all the billions of dollars that they've invested in. So I think we can look for collaboration from those groups. And there's a number out there that are already reaching out to the digital health community saying, how can we take your interest in serious games, your interest in digital health, and combine it with our technology so we can come up with better interventions for health and wellness on the consumer side and better clinical interventions too. Thank you very much.
Thank you very much for that. That was really fascinating, and I'd like to look at it again if possible. There was a lot of information in there. The one concern that I have around this is notions of privacy and who has access to some of this information. Even something like a Fitbit, what's to say that my insurance company doesn't come after me 20 years from now saying, you haven't been exercising and so we're not going to cover you, or whatever?
I share your concern. there's a lot we can learn about someone's health just by how they behave in a virtual environment. How fast they react to something, where they look, where they go, who they interact with. And with AI systems getting better and better to parse that data, I think it won't always be, even in a medical context, that some personal health information will be obtained just from what we're doing out there in the wild. Now, it's a double-edged sword. It's fantastic to be able to collect this data in an objective way to maybe screen if someone's having a healthcare problem and maybe tweak their interventions if we do have better data for them. But you're absolutely right. I think it's an ethical issue that we need to solve and solve soon. There's a lot of work going on in blockchain to try and lock down and secure some of this data in a way that won't be easily hacked. But I share your concern. I'm afraid I don't have an answer to that, though.
Thank you.
Yeah.
Thank you again for your presentation. I was just curious, with the technology nowadays, one of the examples that you had there, I think it was not Clinispace, but it was one where the doctors were learning how to put in a nail or something.
Right.
Why is it not mainstream yet to have something even more simpler, such as doing a wound care dressing for nurses? Why do we not see a lot of these augmented realities in hospitals for training? Why is it not more mainstream? What are the barriers?
It's a good question. Why isn't it more mainstream? Well, the good news is there are a lot of groups, for example, just first aid training, where they're coming up with AR systems to do that, where you can pull up your cell phone, have it overlay on the wound, how to take care of it, et cetera. But many of the startups I work with don't know medicine. They come from the special effects arena, or they come from the technology arena, and they really are still trying to get up to speed. And I can't tell you how many of these groups I have to say, if you're developing a medical product, it doesn't make sense to call it a killer app. But it is coming. But you're absolutely right. And I think part of it is that people, if they do know medicine, they're going at the higher margin, more clinical side of things. If they don't know medicine, they're a little bit shy of how to jump in. But the good news is it's in process.
Just one little question. In terms of simulation, I've kind of broken this down in the area of like serious educational games as an Oreo cookie. One side of the cookie is the graphic user interface. It can be an open world, for example, sign space open. And then you have the other end of the cookie, which is going to be your game engine or your kind of analytics or your teaching engine. In the middle of those two cookies is a simulation space, which for now consists of wireframes, chatbots, relational databases. And I've been speaking with Donald Steiny down in California, in Silicon Valley, and other people about how to create inorganic life, what Yuval Harari calls inorganic life. That is that objects in simulated space that respond and have narrative built into them. Is there any work in the area of the actual simulation of experience that you can help us out with? Thanks.
When you say the simulation of experience, do you mean?
Like a patient giving you their story, and then that patient, you doing something, and then the patient getting better and then getting worse. So that there's actually an evolving narrative dialogue, almost an inorganic method acting.
Absolutely. I should point out some of the work in virtual humans, both at University of Southern Florida, Ben Locke's group there, and then also Skip Rizzo and his work at USC, the Institute of Creative Technologies. They've come up with great virtual humans that you can talk to, ask them about their diagnosis, determine their diagnosis, ask them about their backstory. We don't have enough of that, but the enabling technology is there. And I think that's going to be a very powerful tool, is to come up with some standard library of patients. I mean, we certainly are starting to have electronic cadavers where they have all aspects that you can look through and go through, and some of those electronic cadavers can sit up and talk to the resident and say, here's my history, and this is why I have this problem. And I think that's pretty cool, because it could be a little spooky, but it also adds a layer of personalization to otherwise what would be a very technical procedure.
So as far as we understand, there are either chatbots or relational databases or wireframe decisions still at this point. There's nobody creating, or are there AI bots that people are starting to build, like a dementia patient who's an AI bot? I know University of Ottawa was toying. Anyways, that's my last.
In laboratories, in research groups, yes. Have they escaped and gotten out into the consumer product arena, into the medical product arena? Hey, my time is just perfectly up. But yes, they're on their way, but we could use your help.
you.